Hey guys, welcome to our webinar series. Today we're talking about the JT series with the name of All About JT series. My name is Julius. I'm the Senior Business Development Manager for Hesai Technology here in Europe. And on my side is Christian, which is doing the Senior Program Management.
Hello.
Our today's agenda, to wrap it up briefly, we first want to talk about the product lineup of the JT series. Then we want to talk about the product specifications in detail. We want to speak about the competitive positioning of the product. And at the end, we want to discuss the product applications. So to sum it up very quickly, we're talking about two sensors. The first one is the JT16 and the JT128. So how do they differ? We have an example of iPads. So at first we have the iPad Air and the iPad Pro. And the question is, how do they differ and how do we compare it to our sensors? And in general, you could say the JT16 is very cost efficient and the JT128 is very high in performance. So whether your focus is on different things, you can choose between the two sensors and we will most likely find always a fit for your kind of application.
So let's start with the JT16. The 16 in the name of the sensor is the number of channels in vertical direction. These 16 channels are distributed evenly over 40 degrees vertical field of view. And in the horizontal field of view, it's the complete 360 degree. This sensor is very low in volume. With only 55 millimeters in diameter, 64 millimeter in height, and the power consumption is just 4.3 watt, so also extremely low. Talking about the range, maybe it's a 30-meter range sensor at 10% reflectivity, but the maximum range is still 100 meter. So large objects can be detected way further, but still you have a decent range of 30 meters for smaller objects. Comparing it to a state-of-the-art sensor on the market, we increased the range to 100 meter as indicated. The power consumption is decreased to 4.3 watt, as well as the noise ratio, the audible noise is decreased to below 30 decibel. The scanning method is more advanced, more robust, since we're using a one-dimensional scanner. And as mentioned, the size is decreased tremendously to 55 millimeters in diameter. We are talking about a platform-based product from our end. The JT16 is already in start of production, and we produced couple hundred thousands of those sensors. So it's a large-scale product that we can sell directly. Talking about the volume again, as you can see in this comparison, it's fairly much the volume of a pool billiard ball. But also what needs to be mentioned is just the curvature shape of the sensor. So the top 20 millimeter of the sensor needs to be exposed to the application. Everything else from the sensor can be embodied within your application scenario. So comparing it again with the state-of-the-art sensor, it's 75% in volume reduction by keeping a very flexible form factor, and it's also from a competitive price point decreased. And furthermore, when we're talking about low applications or lightweight applications, the power consumption is decreased by 40%, which generates a higher battery lifetime for the entire device. Talking about the weight again, comparing it to a state-of-the-art 16-channel sensor, you can see even 4 JT16 are lighter than a single typical 16-channel sensor.
Yeah, again, I will hop in to hop on the comparison to Apple products at the end of the day. So you could say it's lighter than an iPhone 15 Pro. And regarding that, iPhones get lighter and lighter, and that's also our vision for the LiDARs. The lighter it is, the better it is for critical applications, for example, on drones or small AMRs. So we're very proud to achieve that as well.
talking about ingress protection and typical test standards. So all of our sensors are tested against mechanical shock, UV aging, ice water shock. They're IP proven for outdoor scenarios. And all these tests are done at our in-house test chambers. So we can guarantee that this sensor can be utilized in outdoor applications exposed to the sun, so there will be no interference with ambient weather conditions or sunlight in general. Coming to the second sensor, the JT128, again, the number indicates the number of channels. So this sensor comes with 128 channels distributed over 94 degrees in vertical field of view. But these 94 degrees are from -3 to +92 degrees. And when this field of view rotates by 360 degrees, you get a complete hemisphere. So there will be no blind spot of the sensor. The sensor can work in dual return modes, so you get up to 2.3 million points per second. And the sensor comes with very much the same volume and shape as the JT16. So it's basically the same housing.
Yeah. All right, so I will take over in the competitor comparison in this regard. So the market are kind of fusioning, you could say. So the JT128 is also qualified for a lot of applications where the JT16 is used. And the decision criteria in this case is mostly the competitive pricing. Regarding the field of view, 187 degrees is unique. It's hyperhemispherical. It's the first LiDAR on the market who can achieve that. The range is as well as 30 meters at 10% reflectivity. The minimum range is always a topic. We're talking here about 0 meters, so you could detect directly after the lens. And as well as for the JT16, the weight and the power consumption are still very, very low. There is a topic called cover lens inspection. We will go into that topic in a few slides a bit deeper. This is a very, very interesting thing for auto applications. Okay, so again, the window height, Christian was mentioning it before, it's at 30 millimeters, which makes it super, super interesting for people which are interested in a advanced design, let's say. So you don't have to protect it that much as if you put like a common or older LiDAR version on the side of the vehicle, so the crashing potential is less lower. The diameter decreased and the volume also. It's the same for JT16 in the end of the day. Then the field of view. I like this visualization quite much because hyperhemispherical sounds cool, but to see it in a visualization, it opens up the perception of a potential customer, you guys as well. So we are 2.5 times bigger in the field of view than a traditional 3D LiDAR like we have it in our portfolio as well. So this means you can mount it in every kind of position, right? You can mount it like you see it here in the video, but you can also mount it upside down or sideways. This is all possible and therefore is enabling just a lot of creativity using this kind of sensor. Then Christian mentioned it before, we don't have any blind spot. On the left side, you see a typical LiDAR, which is also dome-shaped with a 60 degrees vertical field of view, which is enabling already a lot of perception. But regarding to the blind spot, the JT128 is unbeatable. So you see, we mounted it sideways on a device, and the person we want to detect is fully detected as well as the racks in the background, with a precision and also a density which is very, very unique and very useful, especially also for indoor applications. Then Christian, a topic for you, I would say let's hop over with the IMU.
Yeah, so typically LiDAR sensor is used together with an integrated measurement unit, and we integrated this IMU already within the sensor. So the sensor comes with an integrated IMU, and this IMU is already calibrated to the sensor. So you get both data in one. The sensor is sending the point cloud, and with the same Ethernet interface, you also get the acceleration and position of the sensor.
Yeah, so what kind of applicable scenarios do we see for the sensors? So Christian already mentioned outdoor usage. Where can we see such a cost-efficient sensor? The RoboMore market is booming at the moment. So this is definitely one of our applications. But then the creativity is unlimited, let's say. You can use it on delivery robots, stationary applications, which is a huge thing and is growing, especially in Europe, immensely. We have the AMRs and AGV sections, and we have the service robots. So everything that moves basically or is stationary, and you want to have a perception, besides the camera, the JT128 or JT16 is just perfectly suitable. For example, here we have a video from using this sensor. I will just be quiet and let it soak in for you. So thanks to our marketing team, we have this impressive video. I think most of the topics are covered. But one problem we always face with using this kind of sensor, and it's also always a question we get from customers, is what does it make it better compared to a camera? And one thing is definitely the independency of sunlight. So as soon as sunlight is breaching into the lens of a camera, it gets very hard for the camera to see, especially if we talk about a 3D camera. That doesn't affect the sensor at all. And if we look onto outdoor applications, it can be also general obstacles. In this case, a very cute squirrel running around. We don't want to run the squirrel over, so this one can be detected. Also, nighttime operation is very interesting. So if you have the situation that you want to enjoy the sun next to your pool, maybe, you don't want to run or have a lawnmower run around your lawn at the end of the day. So the lawnmower can operate by nighttime as well. And we have uneven terrain, so very steep hills, for example. That doesn't matter for the LiDAR sensor at the end of the day. So you see the potential of the sensor is very, very broad, and you can use it in many, many outdoor applications, which makes it super interesting and super cool, in my opinion. Okay, Christian, so let's have a discussion on how this LiDAR is tailored to robotic lawnmower applications. So to give a business perspective on this one, we had a pilot customer who was requesting this sensor, and you can see all these features, and maybe Christian, you can go a bit into detail again, is very suitable for that. But not only for the robotic lawnmowers. So humanity is just trying to make lives easier in the end of the day. And robotic lawnmowers is just the start. And if you think in that way, it's very interesting on in which direction LiDAR in the end of the day can move in making our lives easier and elevate the robotics at the end of the day. So Christian, maybe just give us a short insight on the features.
Yeah, so the lawnmower is a good example to explain the custom features of the sensor. So for example, the integrated IMU is reducing the weight of the overall application and also the integration work. So you don't need to have an additional external IMU. Everything is already combined within the sensor, limiting the overall weight of the hardware, and that increases the overall battery lifetime, which is mandatory for lawnmower.
For example, to hop in, Christian, sorry to interrupt you, but if we talk about drone applications, for example, every gram counts. If we talk about 50 grams more or less, it can heavily depend on the flight time. And if we have a very critical situation where flight time is very, very important for doing inspection work, for example, this is immense important. So I think you made a good point with that, Christian. It's a cool feature.
Yeah, right. And the other main point of the lawnmower is it's always outdoor, so it's exposed to rain, ambient weather conditions, and especially the sun. So the sun does not need to interfere with the sensor. The sun shouldn't age the sensor, so the sensor is tested against that. But furthermore, when we talk about the ambient weather, as you can see, there are some raindrops on the sensor. There is an integrated blockage detection or raindrop detection on the sensor. So the sensor can indicate whether there is blockage on the sensor, and then the robot lawnmower can drive back to its station to clean the sensor. So that piece of information is also coming from the sensor, again, limiting the additional necessary hardware and increasing or limiting the weight, increasing the battery lifetime. And that can be also translated to other applications, like Julius mentioned, with drones or other lightweight robotic agents.
Yeah, then we also have the point of low noise. And I just mentioned the nighttime operations. And who doesn't know it? You have a fridge in your flat, maybe you have a two-room flat, leave the door open in summer. You try to sleep, and all of a sudden your fridge turns on and it's summing the whole night. Makes it very hard to sleep. So also the low noise is quite important. So if you let you run the lawnmower, for example, during nighttime, you don't want to hear the sensor summing the whole time when it passes your bedroom. So this is also a very important thing, which is not always considered as an important thing. But in the end, if you compare two products, which is loud or not loud, you would always go for the product which is more quiet.
One other comparison that we would like to make is RTK plus camera versus our JT sensor. So JT sensor is basically LiDAR plus integrated IMU. That's the point of the slide. So when we say RTK plus camera, we have basically GPS data, which can be as precise as 1 centimeter. However, this always depends on the satellite information. So it cannot be guaranteed at all times that you have a high accurate SLAM data. But on the other hand, when the IMU, so the measurement of the position and the acceleration, is already integrated within the sensor independently of any GPS data or satellites, then you get always precise SLAM data in indoor and outdoor applications, and you get directly a 3D point cloud map instead of a 2D map of the scenario. Talking about other applications where we can see the achievement of a LiDAR versus a camera going from left to right. So there's, for example, high-low contrast. So a white, small-sized object in front of a white wall is not really visible for a camera. On the other hand, in the middle image, there is a red object which is directly exposed, so it should be visible to the camera, but it's not yet trained for the camera. But the LiDAR itself doesn't care whether it's a red object or a white object. It will always detect this object as a 3D data point cloud, regardless of the shape or the size or the color. And last but not least, night vision for sure. With a camera application, you cannot see differences in very low light conditions. However, a LiDAR is an active sensor, so it shoots lasers, receives its own laser, and based on that, we can also see directly in the night vision that there are multiple pedestrians running around, versus the camera would just ignore those pedestrians. Yeah. As mentioned, the sensor comes already with an integrated blockage detection, and this is based on our waveform processing engine. So based on how the light is being received, we can understand whether this is an actual pulse from an object or a pulse from a blockage directly on the lens. And this is a very good indicator for the application to determine whether there's a blockage on the lens or not. And this indication comes on multiple levels. And depending on the level of the blockage, the application or the user can decide whether it's time to clean the sensor or whether it's time to return back to the station.
Cool, thank you, Christian. So I will take over for the AGV applications or possibilities you can have. So we talk about different kind of applications, and especially in this market, in-house logistics or intralogistics, it's very important to be safe at first, so be machine safe and personal safe. So on the left side, you see the obstacle detection topic. So the forklift is still driven by a driver, but he's reversing. And if there's an object in the way, for example, a box or a pallet, or even the fork of a forklift, this is a very, very critical information needed if you do that. You want to have an information for the vehicle and for the driver if he can continue driving or not, or even in the most extreme case, to stop the vehicle before it crashes. So with the density of the point cloud, especially of the JT128, you were able to perceive that fully. As shown on the right, you will have the full coverage on the back. As on the left, you have two 2D lidars trying to kind of catch it, especially for the forks laying on the ground. It's very, very impossible for those lidars to detect, or even when they detect and the driver is too fast, you will crash anyways. And that's like the biggest plus point for 3D lidar in those kind of applications. Yeah. Then a second thing, Christian already discussed it for the lawnmowers. We can enable SLAM, which means on the left side you see 2D SLAM happening, or 2D localization in a warehouse, which is quite cool, which in some cases takes place with reflector stripes and a single point lidar, 2D lidar on top, which is cool. So you have the layout, kind of looks like a robotic vacuum cleaner in your house when you steer the app on the left side. But that's not what we're trying to achieve and where the future is aiming for, right? So with a 3D lidar and a SLAM algorithm behind it, you're able to completely map the whole environment where the vehicle is moving, and you get also valuable information added to that. So not only the obstacle detection point, but also to navigate fully and to dodge also obstacles which are on the way, to find new paths for the vehicle. This is a video take place in our warehouse in our Maxwell Center. It's just to showcase how detailed the point cloud will look like in the end of the day if you post-process it, and how you could utilize it in your warehouse to get as much information as possible.
Yeah. And maybe one point on this, this data that you can see here is just based on a single handheld sensor with the integrated IMU. So there's no additional necessary hardware. You just have the sensor in a handheld device and can walk around your factory or any other warehouse and get this precise SLAM data out of one single device.
Yeah, maybe if the SLAM topic is interesting for you, we also sometimes talk about the drift while doing SLAM, and there also JT128 is exceptionally good. So in the tests we did so far, and I was a part of it, we don't have any drift within the SLAM, which makes it super easy to integrate, and is also eliminating this pain of redoing it again or post-processing it over and over again to get rid of this. It's also very efficient. Yeah. Then also a point at AGVs. We have a sensor stack which is super expensive. So we have a lot of 2D lidars, we have a lot of 3D cameras. In the end, 9 to 15 sensors, even depending on the vehicle you're looking at. We try to eliminate that as much as possible. So with one single JT lidar, you are able to eliminate various sensors on the vehicle. In the end of the day, we all talk about costs. You're able to reduce the amount of hardware of different suppliers. That's the first point. And the second point, you will get even lower in costs. So it's a win-win situation if you're able to invest the time of integrating the lidar at the end of the day. And it's in 99.9% always worth it. Then Christian, maybe you can give us an insight on stationary applications. Maybe I can give a short introduction to it. So if we talk about safety, not safety, so stationary applications, it's traffic sensing, for example, crowd sensing, so being placed in a shopping mall, for example, providing the data to the single shops which are renting in the place of the mall. We have the intrusion detection. So if we have critical places, for example, a camera is good, but also during nighttime, not very reliable. So a LiDAR could be used in that as well. Or even vehicle marshalling. We have a very good pilot project, have a lot of videos online regarding that, which is doing valet parking at a very big OEM here in Germany. So also here, the creativity just is immense, and we don't want to set you guys boundaries. You can just, in the end of the day, be free and come up with your applications towards us.
One point regarding those stationary applications is coming back to the complete hemisphere of the sensor. So there's no blind spot in the sensor. Basically, when you look at the bottom left corner in the image, there's just a single sensor mounted at the side of the wall, and this sensor can scan the entire room. So there's no need to play around with multiple sensors to scan in all corners of the room. One single sensor can be utilized to cover the entire area. Same as for the vehicle marshalling. You don't need to place multiple sensors in different tilt angles to trying to see every single corner between the cars, in front of the cars, behind the cars, to detect every single obstacle. Just having a couple of sensors looking directly from top of the ceiling downwards facing to the vehicles, you get a really nice point cloud of the entire application.
That's a very good point, yeah.
Coming to this comparison, camera versus LiDAR, for those kind of applications, you can see in our LiDAR image, a human person is visible as a human person, but there is no face recognition possible. So the privacy is fully protected and the data is secured, as we can't perceive any more detail than this point cloud information, which is not detailed enough to get facial recognition.
I think this is especially important if you use it on a complex of an organization. So the topic of data security is always big if you talk about production or even private property, let's say, because outdoors you always have the CCTV cameras, in some countries more, in some countries less, but this is not that big of a problem, but especially within an organization's environment, this is very, very, very important. It's a very good point, Christian.
Yeah, looking at this video, we can see there's just a single sensor, a single JT128 mounted at the ceiling facing downwards to a crowd of people. And all these people are detectable, so the perception algorithm can count those people, can calculate how many people are walking in which direction, but still you don't get any problems with facial recognition. And the entire room is visible with just a single sensor.
Yeah. All right. Thank you, Christian, for your input. I hope you guys enjoyed it. For the guys who want to stay with us, we have a Q&A prepared for you. I will ask the questions to Christian. He gives us an answer on it. If we don't cover the questions which are popping up from your side, just feel free to shoot us an email and we will come back to you as soon as possible. In general, we are able to answer, let's say, 99% of all the questions that are popping up. Okay, Christian, so now the first question of the day. Can the JT16 also support dual return mode? Because we talked about this for the JT128, and I think a lot of people are questioning, is that also possible for the JT16?
Yeah, well, unfortunately, that's one of the limitations of the JT16. The JT16 comes in single return mode only, which is basically a limitation of the interface, which is RS485.
Okay, thank you very much. Then the second question. What connector type is used at the JT16 for the RS485 connection, as you just mentioned?
Yeah, so the JT16 is not using a typical Ethernet interface. It's using a connector which can be directly connected to a circuit board with just a single interface. So there's no connection box needed to mount the sensor on the circuit board.
But also, if you guys are not willing or able to do that, right, in like when starting testing, we have a connector box which we can deliver, and it's mostly used for R&D or testing purposes. So you don't have to worry immediately how to wire the sensor to the board. All right, then the third question. Does the IMU to point cloud offset needs to be calculated in post-processing?
No, it does not. There is a directly internal processing of the IMU data. So the IMU data's center of the coordinate system is directly passed to the sensor's origin of the point cloud. So the data that you're receiving in whatever interface is mapped from one coordinate system to the other coordinate system. So you don't need to take care of that. Maybe to this point as well, the sensor is sending PCAP data, but also you can go to our GitHub page to find our SDK and ROS integration. And here we can also see that the IMU data of the sensor is directly coming from the very same data stream. There's no post-processing needed.
Okay, cool. And then, can JT128 function properly in harsh weather conditions? We also covered that topic, I think.
Yeah, I think we covered that quite a lot already. So yes, it can. However, if there is an extremely large blockage, you get your blockage detection from the sensor, indicating that the sensor should be cleaned. However, if there's, let's say, just rain, dust, snow, you still get a decent point cloud. And the sensor will not be damaged from the weather. So it's certified IP67, so it can operate in those outdoor scenarios. And as mentioned, you get a decent point cloud. So feel free to test our sensor in very ambient weather conditions.
Thank you. And then, why is the JT128 vertical field of view design set to 187 degrees exactly?
Yeah, so the 187 degrees comes from basically the 94.5 degrees, which is for one scan, and this scan rotates by 360 degrees, and it's from a negative inclined angle to a slightly more than 90 degrees. So the negative of minus 3.5 degrees is to see the ground when the sensor is mounted horizontally, and plus half a degree, so the 90.5 degree, is to see everything on top of the sensor and account for production tolerances.
Yeah, maybe to hop in from the BD perspective as well. So if you decide to mount the sensor upside down, the minus 3.5 degrees, or in the end product even minus 4.5 degrees, can enable to see up the walls or even the ceiling, depending on the range or the size of the warehouse you can have. So this is also very interesting, because mainly for obstacle detection, you're interested in overseeing the ground and seeing forks or pallets and so on. But also this can enable to see maybe pillars standing in the way or something hanging off the ceiling. So that's also a reason which enables this, or why we decided to go into that direction. So yeah, that's already it from our side. Thank you, Christian, very much for your time and your attendance. Thank you guys for tuning in. And yeah, stay tuned for our webinar series. Very soon there will be a series starting. And yeah, thank you for attending.